But I think that this is the place where a lot of this stuff is happening. So why, now that, let's go into the slideshow here from the beginning. And we're, oh good. Okay, great. Not sure why. What I thought I'd do is I thought I would talk to you a little bit about sort of the emerging industry we have here in this area. We're kind of in, not kind of, we're in Marine Robotics Central. There's a lot of great and exciting companies emerging here with new products, and of course we have a lot of the educational institutions which are training the new people and doing some of the cutting edge research, which maybe 10 or 15 years down the road will be the next generation of products. So why don't we think a little bit, the idea here is to kind of throw some ideas out, get the conversation going about where we're going and what we need to do together to be successful here on the East Coast and in the world in general with marine robotics. So first of all, I think we've come a very long way. Not sure why I'm not advancing here. Okay. Well, no, I've got it on a different laptop, although I suppose it's not totally impossible. Tell me what you want to do. I want to advance. Okay, I will try killing this. And we'll try opening again. There we go. Like most electronics or like most software programs, if they don't work first, reboot. So, so for me, you know, my first real experience at sea was in the Antarctic, and so this is 1993. Off of this? Yeah. Okay, great. So 1993. In the Antarctic, this is actually off of Anders Island. That little vehicle in the front was our first Odyssey vehicle. It's got the top fairing off. It had an endurance of about 2 hours. It was sort of nominally intended to be a deep-rated vehicle, although you all know with these free-flooded vehicles, your rating is kind of only as deep as the shallowest system in it. And probably the worst part of this vehicle was its data logging system. It had actually a terrible. It was very difficult to get good data files off of it. A big lesson for me. Now, if you kind of come forward to today, of course, you know, if we talk to some of our big companies here, they're dealing with using robotics for real naval applications increasingly. In the air, there's a move to take that X-47 and turn it into, I think they're calling it the Stingray, a tanker, which would fly off of aircraft carriers. We have autonomous surface vehicles, which have made the transition from DARPA to ONR to now beginning to lay the groundwork for programs of record. And of course, the submariners are really beginning to adopt autonomous underwater vehicles in a big way as well. And I think that's one of the groups, by the way, that Toby, we might want to think of including next time. You know, we have New London not so very far from us, and we should get some young submariners in the room because they're thinking hard about how they complement their platforms. It's a long way that we've come in a very short period of time, and expectations are high, right? If you sort of go down to Washington and walk the doors of the corridors of the Pentagon, they're really expecting these autonomous systems to really save us because, you know, that bottom platform there, that nuclear submarine, that's a several billion-dollar platform. And we can't afford very many of them. As a matter of fact, right now, the numbers are declining, the threats are going up, and they're hoping that the autonomous systems are going to be what save us. On the science side, and these are vehicles that I've had a hand in, we've gone from very short endurance vehicles to longer vehicles. That vehicle in the back actually has a 6-kilometer rating and carries a fairly impressive mapping system, but still is married to the ship, deployed in the morning, recovered perhaps the next morning. Vehicle in the front there runs several weeks. So those vehicles and carries a fairly comprehensive payload for biology. So we're beginning to move on the science side away from our tight dependence on the ship in order to do interesting and useful work in the ocean. And I think as we go forward, part of the question here is what's next? What are the next set of systems that we're going to have? And as you walk around here, you can ask that question as you look at the various tables, because you can see a lot of the elements. And they're driven many times by technologies that are outside of our world. So you could find many of a number of different types of graphics here on the advances in batteries. Now, energy density advances aren't really that dramatic, if you think of them compared to Moore's law and computer chips. But if you think of them in terms of cost, the cost per kilowatt hour, actually they have been pretty impressive. And of course, they're driven by mobile electronics. And increasingly electric cars are producing large battery sets. And I think we all remember, or many of us anyway, remember the early days when some of these early batteries were pretty scary, right? Did you really want to put it in a pressure vessel? Would you dare charge it? What would be the conditions you would charge it? What kind of battery monitoring system? If you talk to the battery manufacturer, what kind of failure modes might you expect? I mean, all of those things were question marks, but increasingly we're beginning to be able to really work with these batteries and use them in some fairly large assembled packs. Now, in addition, of course, here we are, we think of ourselves as robotics, Marine Robotics Central, but actually this area also is a center for additive manufacturing. And additive manufacturing, as you walk around here, of course, we can all point to products, right, which either started as prototypes created with additive manufacturing technology, or which are actually produced directly. And the old additive manufacturing of stereolithography and then depositional techniques, those all continue to evolve. So right up in the Boston area, we have Desktop Metal, right? A little multi-billion-dollar valued startup, which is literally putting desktop fabrication, in something sort of about the size of this podium here, for a few $100,000, down from the sintered systems, which were, of course, a couple of million. So these all, of course, we know, right? When you think about the software design cycle, how differently you manage things. You go from sort of very classical engineering management methodologies to agile programming techniques, because you have the opportunity to learn lessons while you're still in the design process. And increasingly in the mechanical space and even the electrical space, we're able to do that as well. And so I think this has some real, there's some real questions here. I mean, my rule of thumb in the oceanographic world, this is painful even to say out loud, but it's roughly a decade from that back of the envelope sketch to something's working in the ocean that somebody else can use. And how can we shorten that? And a lot of that really involves with how we manage the design process and how we move things from design into manufacturing. So big opportunities there, and by the way, when I go around to the additive manufacturing companies, a lot of them don't know about us. So when we tell them, look, these properties of the plastic materials you produce just don't work for us in the ocean. They're porous, or they have strength issues. They go, wow, we didn't know that. We didn't know about your market. Have you tried this material? There's a lot of opportunities there that I think we have, and I think some of you are already working on this to work and connect with these other industries and have them think, the metals they're producing, they're doing, they do a lot of steel stuff. Of course, they don't do aluminum. There's good reasons why, other than sintering. Aluminum is a very tough one to do. But titanium, most of them could do, right? If you ask them for. And then, of course, the other thing is that increasingly we're learning how to use the environment again, which is a little ironic because this is really where humans started out, right? We were probably initially paddling on a log, but then we very quickly figured out how to use wind. And now our autonomous systems are using wind, and they're using wave, and then the profiling systems are using thermal gradients in the ocean. Just a bunch of discussion at Woods Hole out of some phys rev paper, out of some strange material which expands when it contracts figure out the thermodynamics on that one. I challenge you. Big discussion, but it's in phys rev, so there's some real reality there. Now, and most of us who build platforms, of course, recognize that you can bring your platform costs down, but as soon as you stick regular sensors and navigation systems on board, the whole cost of the system goes up. And there's good reasons for that. There are not real markets of scale that have been around in the undersea industry that would really support the move across to high numbers manufacturing. But we do know there are existence proofs there that in fact you can get really high performance sensing systems at low cost. And these examples here are from the medical industry. So there's folks that specialize in there's labs, for example, there's one I used to work with out at UCLA, that take cell phones and they figure out, for example, how to make a flow cytometer with like $25 worth of additional parts, and then it can be used in someplace in Africa or someplace in South America where you can't bring somebody to a clinic, but just about every other person has a cell phone. Actually, more than usually 80% of the people have cell phones. Now, the other thing that's happening, of course, we all recognize is that AI has coming through a new renaissance. Is it a bit oversold? Probably. Will it be transformational? Almost surely. Here, this is now a couple of years old. This is IBM Watson, is recognizing whole concepts, inferring complex relationships and answering tough questions. Maybe a little more impressive was the AlphaGo success over the Go Master. And then, by the way, once they did that, and that was about a year ago, they then went back to the lab and they trained a new AlphaGo, which beat the old AlphaGo, which, by the way, most of the problems with these systems usually revolve around the fact that they have to be trained by humans, in effect by human examples, and you need very large training sets. And the thing that was really interesting about the recent AlphaGo success was the robots trained against each other. And they basically figured out their strategy from scratch, and in a matter of weeks had evolved to being better than the best computer system, which had already beaten the best grandmaster. So these things are very real and changing. Are they stovepipe? Yes. Do they apply to what we do? For sure. And one of the problems, of course, we have in the underwater environment is that our systems are typically using different sensing modalities than the other environments are. We're also lower power, and we usually don't have the large training sets. So this is an example actually from Yogi Girdhar, a researcher at Woods Hole. He does work with topic modeling-based machine learning approaches. And over here you can see his robot swimming around. This is actually his PhD thesis. And on the right screen you see what the robot sees, and the red dot is what the robot finds most interesting. So this robot is actually on the fly building a classification of the undersea environment. When it encounters a new scenery which is not well described by its previous classification, it actually is perplexed by it. So and not only that, but it is programmed to focus on it. So this is a robot which in effect can detect something you didn't tell it to detect, and is curious about encountering things which it hasn't seen before. And it sounds, it kind of looks fun and maybe a little frivolous. If I had more time, I would show you how we applied this to detecting failures on systems which are unanticipated. So which neither the programmer nor the operator anticipated, and by the way, did it much better than the best systems that we were able to develop on our own. Now, of course, if you take these AI systems, you start running into some real ethical questions. And those of you who have been following developments in the self-driving car world have probably heard about some of these ethical dilemmas. You're in a self-driving car, and there's a lady with a baby carriage, and the car has a choice. There's an oncoming car. Should it avoid the oncoming car and crash into the lady with the baby carriage, thereby killing them but saving you and the oncoming car, or should it crash into the oncoming car? So these are the types of very real questions, and you can come up with a zillion scenarios like this, which are real ethical issues that we begin to have to deal with our autonomous systems. And once you start dealing with them, of course, in the military side, you start asking questions about the use of them. Now, I think that, this is a slide which I've shown before here, robots are for everyone, and this is sort of very connected to that, and let me just sort of follow the thread through. Number one, we can all go buy our own robot, right, from Amazon. What's more, we can download our own autonomous software from the web and load it on that robot and do autonomous things. We can have our drone fly around and fly specific patterns to places, for example. Now, that's pretty exciting stuff because it greatly lowers the entry bar for working and contributing to this field. So you expect things to really accelerate. The problem is that it can be used by everyone. So from a defense perspective, the autonomous genie is out of the bottle. Kind of everyone can do this. The Marine Corps actually ran a project that we called Combat Shopper, which was to take a look at, if all you had was a credit card and access to Amazon, what kinds of things could you do that would make life difficult for the Marine Corps? And let me tell you, these little robots are definitely in that category. And of course, I think that the other part of this is education. So one of the things that I just want to pause and maybe mention for a moment, I know Elon Musk gets very overblown, but again, if you walk around Pentagon, you will definitely encounter people who worry about Skynet. Now, for those of us working on our autonomous underwater vehicles, our reaction is, if only, right? Our robots are so far from self-organizing and taking over the world, that it's kind of a funny concept in one sense. But in the other sense, maybe that makes now the time to deal with it. Do we have an ethics of developing autonomous and robotic systems? If you think about, my background's actually a physicist, so my PhD's in physics. And as I came through the physics world in sort of the late 70s and early 80s, there was a lot of discussion about nuclear weapons, and was all knowledge necessarily good? And when the genomics folks began to do genomic experiments, they very quickly took a step back and organized and decided what kind of work was ethical, what kind of work was not ethical, and how do you manage that work which is on the boundary? So we're not there yet, but I think it's something that we should probably think about and start to organize around before someone else who knows a lot less about it does it for us. Now, one of the other things that's happening is that, of course, funding is changing. So this is in the long term. If you look back to, almost going back to World War II, you can see back originally, of course, most of the R&D funding in the U.S. was from the government. And in fact, there was a paper, Science, the Endless Frontier. It was written by Vannevar Bush. It's a 36-page document. If you haven't read it, you should. If you're working in the R&D world, because it really laid sort of the foundation, the social contract for what has really supported all of us since then. But what you can also see here is that the fraction of R&D funding which is being carried by government is a smaller and smaller fraction as industry puts more and more in. Now, of course, in the U.S., a lot of that is in the computer world. And in our world, we're still largely, I think 80% of the business of most of the companies in here sort of traces back to government in some way or another. But I think that's changing. So take, for example, the autonomous car world, where if you look through the lists of VC-funded activities, they tend to come out up there in the top 10. Then what you can do is you can take a look at it and you can ask, well, what's happening with those companies? Well, most of them are getting acquired by the big auto majors. Why are they getting acquired by GM and Toyota? Well, because these self-driving cars are an existential threat. If you're Ford and somebody else comes out with a self-driving car, or better yet, a self-driving electric car with reasonable range, you are just out of business because everyone's going to buy that. There's going to be the market for petroleum-driven vehicles, which human drives, is going to evaporate. So in our case, we are beginning to see some elements of that. So I think people in this room have been part of this cycle of success, right? Where you started small companies, probably bootstrapped, friends and family, built them up to a certain point, and now they're beginning to get bought out, right? So L3, one of the sponsors here, acquired 2 of those companies. Bob back there, is going to be up here next year telling us about the life after entrepreneurship, and in the folds of the large venture. An important set of lessons, I think, that will come out of that. You have companies beginning to go public, I guess on the Australian exchange in that case. But these are each one of these, creates a bunch of successful people, and then a bunch of you who work in those companies are going to go out, and you're going to sort of think to yourselves, that wasn't so hard. I'm going to go do this, and you're going to see a set of what I call alumni companies. So I think Bluefin at this point, which was of course, my touchstone, I think at this point has like 7 or 8 alumni companies, and those will hopefully, what we want is we want them all to stick here in the area. So, final set of thoughts, of course, is that what we're doing is we're enabling other ocean industries, and I've showed this slide before. There's oil, there's offshore wind. Offshore wind, by the way, we'll talk a little bit about because it's becoming much more real. But let's just say that as these industries do their business in the offshore environment, they change the offshore environment. So it's not, if you go down to the Gulf of Mexico, it's not the same Gulf of Mexico that it was 50 years ago. There's pipelines, there's cables, there's infrastructure. And if you think about it, from a robotics perspective, for an instrumentation perspective, that's an incredible opportunity, right? Because that's a whole set of infrastructure there in the offshore environment that in principle could support all of those other operations. Now, of course, that's not how it evolved. Furthermore, there's sort of an element, perhaps, of risk associated with these as well that we have to recognize and that has to be managed. And I think that in particular, as these move to some more remote environments, you think about ice-covered oceans, which are not quite so ice-covered anymore. How do you get to those in the case of disasters up there? By the way, I'm disappearing from this meeting because we have a DHS review of a project we're on for responding to oil spills under ice in the Arctic. So this is something that people are beginning to work and think about and invest in. But if you look at here a little bit closer to home, what you see is the rise of offshore wind, we hope, right? Or at least I hope. And if you look at our area, we have a lot of that area there. The color bars in this basically are saying, how favorable is that region for wind? And winds are roughly twice as high offshore as they are on land. The power that you extract from wind roughly goes as the velocity cubed. So when you double that wind velocity, you get 8 times the power. And as you can see, that offshore environment is a really great place. And all of this means that, increasingly, and there's a couple of big projects now, which are going to go in sort of down there, Dong and so on. I guess they'd be named themselves. So now what you have is you have an opportunity, conceivably, to sort of do in Massachusetts and in New England and on the East Coast, what was done with oil and gas, but maybe do it a little differently. So this is a slide out of actually I think it was a set of French authors. But it's an idea that a lot of people have talked about. Once you put that infrastructure out there, you can actually think, by the way, if you stuck an aquaculture cage, a reasonable size aquaculture cage around one of those wind turbines, sort of roughly the number of people you feed, is roughly sort of the number of people you provide power for. So there's kind of a synergy there. And so I think this is another thing where, as a community, we actually have a very strong vested interest in seeing wise use of the offshore. So my colleague Leslie Ann McGee actually worked in this marine spatial planning business for a while. And so this is an area where we as a community really have an interest in seeing that infrastructure that's put out there actually can support a broader range of activities, can support monitoring so that we know that we understand our impacts on the environment. So I've kind of used this slide all the time. We do have this ecosystem of robotic enterprises here in the general New England area. If I expanded this up to Halifax, as you can see from the corridor outside there, there's a whole slew of additional companies that are working in our space. It's very exciting times, but I do think it's time for us to begin to think a little bit more, Rhonda, since you took up the reins, to think about the types of things that we can do to organize for the future, to ensure that in effect not only our market but the markets that we depend on are successful and grow in a way which ensures that we have a constructive and productive use of the offshore environment. So it's a pleasure as always to be here, and I think with those comments I'll end this. Thank you for inviting me.